Welcome back. We're going to look at section 2.1 today and looking at graphing and the value of a piecewise function. We've worked with piecewise functions. You've worked with them in Algebra 1 probably a little bit to get to know them. Algebra 2 we worked extensively. Pre-calculus we worked hopefully extensively on them as well. So I just want to bring that back to the forefront of your mind, and hopefully they make a little more sense this year. If not, ask some questions and we'll hopefully get them to make some more sense to you. So what is a piecewise function? To start with, I guess, should be the first thing we talk about. A piecewise function is a function, so we're going to note it as f of x. It's going to pass the vertical line test for us. And it's going to be made up of a couple of pieces. It could be an infinite number of pieces, really, but normally 2 to 3 pieces is all we're going to work with in here. So we have this top part, x, if x is less than or equal to -1. So we're restricting this function, x, for only the values at x are less than or equal to -1. And at x minus 1, if x is greater than -1. So again, these are our restrictions on the x value, or the domain of this portion of the function. So how do I find the value of a piecewise function? To find f of -2, I'm going to take this -2, plug it in for my x value in my restrictions to see if it makes sense. So -2, is -2 less than or equal to -1? Hopefully you say yes. Is -2 greater than -1? Hopefully you say no. So you know that we're going to work with this top portion. We're going to take that -2, that x value, and plug it in for our x values here and simplify it. If I plug in -2 for x, I get -2 out. If I have -1 for my x, again, where does it make sense? Is -1 less than or equal to -1, or is it greater than -1? And hopefully, again, it makes sense in the top portion. So we're going to take that -1 and plug it in for the x again, and we get -1 out. What about f of 0? If I take that 0 and plug it in, it does not make sense now in the top portion. 0 is not less than or equal to -1, but 0 is greater than -1. So we're going to take that 0 and plug it in for the x values here, and we get -1 out. 0 minus 1 gives us -1. To graph it, some of you are going to be able to see this pretty quickly, and you're going to be able to graph right off the bat. No problems. Others of you are going to struggle a little bit. So hopefully this will make a little bit of sense and maybe a few less struggles. So we're going to look at the restrictions that we're giving. We're given that restricting x at -1. So we could draw maybe an imaginary line down through here, not required, through -1. We know that when x is less than or equal to -1, we're at x. X is a linear function. We have the less than side here, we have the greater than side here, and the equal to side here. So this graph is going to exist in this portion, including this line. What does x look like? It is a linear function. It's going to come up. It would go through 0, but we're not going to go through 0 because it doesn't exist over here. So we're going to come up at a value or a slope of 1 over 1. It is going to go to that point at x minus 1 if x is greater than -1. Here, again, it's going to be a linear function. We would start at -1. I can do that since it exists over here. And then we're going to come up 1 and over 1. Again, it exists over in this portion, so we can go ahead and graph it. Now, if we work our way back 1 and down 1, once we run into this line, we stop and we think, are we equal to it? No. So we're going to put an open circle at the end of that. Now, another way you can look at that, if that was confusing, go ahead and graph this function, y equals x. Remember, f of x means y. If y just equaled x, don't think about any of the restrictions at all. If I were to graph that, it would look like this. Now put your restrictions in. So I'm going to cut it here at -1. So I'm only interested in this portion of the graph. So that portion is going to come down here. X minus 1, if I were to graph that, I would start at -1, I would come up 1/1, and I would draw in my line. Again, we put in the restrictions of -1, so I cut my graph at -1. I'm only interested in the greater than part or portion. So I'm going to take that, I'm going to put it on this side. It's not equal to, so we have an open circle. The other part was equal to, so we put the solid circle on that one. And hopefully if it didn't make sense graphing it, maybe looking at the overall graph and then just taking the piece of it that we're interested in, it will make a little more sense to you. So f of x equals x if x is less than 0, 2 if x equals 0, and x squared if x is greater than 0. Now we have 3 parts to our piecewise function. So can we find f of -1, 0, and 2? By plugging -1, it makes sense in the top part. Replace my x's with -1, I get -1 out. 0 only makes sense in the middle part, so I plug in 2 or 0, I get 2 out. And f of 2 makes sense in the bottom portion. Plug 2 in, 2 squared gives me 4. To graph this, x if x is less than 0, so my restrictions, I'm restricting it only at 0, so I can think of my imaginary line through 0. X if x is less than 0, so that's a linear function. My slope is 1. I would go through 0, 0. We cannot equal 0, so it's going to be an open circle. And my slope of +1. Remember, when we do a slope, we come up 1 and over 1, so up and then to the right when we read a graph. So the slope is up 1 over 1. 2 if x equals 0. So that tells us that it's just going to be a point. At 0, the x value, the y value is 2. And then x squared if x is greater than 0. That's a quadratic. Again, we would go through 0, 0, and we would come up exponentially. We go 1, 1, and then 2, 4. So that would be our graph there. Again, if you want to piece it out, you want to graph those out. X equal x if x is less than 0. So x looks like that. We're only interested in this portion of it. So we're going to take that and bring it down. We're not equal to, so we put an open circle. X squared if x is greater than 0, so we're only interested in this portion of our graph. So we take that and put it on the right side of 0. Well, what does 2 if x equals 0 mean? So we can graph that. That's just a linear function as well, y equals 2. So that would be this graph here when x equals 0. So we're only interested in that point right there, and that's the point that we graphed. I have one more. If we're given f of x equal to x if x is less than -2, 3 if it's between -2 or equal to -2, and 4, and x squared minus 5 if it's greater than 4. So f of -5, it's going to make sense in this first part. -5 is less than -2. So thinking -5, plugging in for x, I get -5 out. F of 3 makes sense between here. -2 is between -2 and 4. Plug my 3 in, I get 3 out. F of 4. 4 is not less than 4, and it's not greater than 4. 4 is equal to 4. There's no equal to symbol, so we cannot plug 4 in to any of those parts. So it is undefined. And f of 7 makes sense in the bottom one. 7 squared minus 5 gives us 49 minus 5, or 44. To graph this, notice I got a bigger piece of graph paper here because it's going to be a little bigger for us. You do need to have some graph paper. I do expect to see these on graph paper when you turn them in. If you want to cut little squares out and put them on your paper, that's fine. If you want to do all of your assignment on graph paper, that's fine too. But make sure you do get some graph paper so that I'm seeing some nice clean graphs. So x if we're less than -2. I like those linear functions today, I guess. So here we are cutting it at -2, maybe a slight dotted line in there. Again, you can put the dotted line in there or not. It's not going to be a big deal to me. But ideally, we wouldn't have those in there because we don't need it. So -2, we're less than -2 for x. So we're going to have an open circle at -2, -2. And we have that slope up 1 over 1, reading from left to right into that point. Again, if you want to look at that graph, the graph is going to go through 0, 0. There's the graph of y equals x. We're only interested in when we cut it at -2. 3, if we're between -2 and 4. Again, y equals 3 is going to be a horizontal line. We're only interested between -2 and 4. So between -2 and 4, we can equal -2. So we'll have that solid circle. And if we come over all the way to 4, and we're going to have an open circle there because we cannot touch at 4. And then x squared minus 5 if x is greater than 4. So what does that look like? Well, that's, again, parabolic. We start down here at -5. And it's going up in this manner. So with this one, a little more cumbersome, you may want to plug in some points. So I know we're only interested in this portion of it when x equals 4 or larger. So if I were to plug in 4, I would get 11 out. So I come over here to 4, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I were to plug in 5, I'd get 20. 20 is going to be way up here. So I know it's going to be an open circle there and all the way up. Make that an open circle. There we go. So it's not going to be exactly perfect up there, but that's what we've got. Now I could ask you for domain and range, just a little addition here. For my domain and my range, my domain I ask for what are all my x values that I can get. Well, my domain I can go from -infinity all the way across until I hit 4. I have open circles there. Here, notice I have a closed circle, so I can touch at x equals -2 only here. So my domain is -infinity to 4, union 4 to infinity. Notice up here, x is less than -2, x equals -2 here, so that takes care of that portion, but we don't equal 4 here, so that's going to come into our domain. Our range is going to be -infinity. It's going to come up to -2, but we don't touch -2 there. Union, then we jump up to 3, but we touch 3, so it's bracketed 3 to 3. And then union, we come up here to 11, and it goes to infinity. So notice we don't have anything in this portion. We don't have anything in this portion. And that gives you an idea of our domain and range if a question were to ask that. Good luck and happy times with your piecewise functions.